Alright guys, I'm going to start to catch up to you. Got a head start on me. What do I have to identify in number one? What should I identify for myself first? What do you know? What variables do you know?
The number, probability.
Yeah, so n is
26.
26. P is
23.
right. Q is
0.77.
77. I like it. And this first problem. So that's true in this series of questions, period. That's number one. That's what's true. And this should feel familiar, like with sort of word problems, whatever, you want to accumulate everything you know and then start actually trying to do something. So what's the formula for 5 successes? How would that look?
26.
You got 26 people.
NCR.
Good.
5. And parentheses 0.23 to the 5th power.
Yeah, let's real quick. Why does that make sense? Because what is 0.23? It's the probability of success, and I want 5 of them.
And then
So it's a little repetitive, which is fine.
0.77 to the 21st power.
Yeah, why 21? Because if 5 of them successes, the rest of them have to be failures. Cool. And now, Jeff. Forgot his calculator. What do you guys get for that?
0.175.
You want a good one? I got my good one. 0.175?
That's what I got.
Neat. Let me catch up.
Okay.
26, choose 5. I got 5 of these. Shit. And then I got 21 of those. Yeah, dude, that's what I get too. Look at all those zeros. That's freaky. I'll be honest with you. I did not set that up. And I don't know if anybody else, but that's just neat to me. Okay. You don't see that all the time. Bam. So just under an 18% chance that out of any group of 26 Americans, exactly 5 of them are satisfied with the way things are going. Intriguing. All right. More than 2. Why does that question suck? What does more than 2 mean?
That means that you have to do 0, 1, and 2. And
Hold on.
Okay.
Wait. No.
Yeah.
What does more than 2 itself mean?
So it's going to be 3, 4, 5,
Yes.
all the way to
All the way to freaking
26.
26, right? So more than 2, 3, 4, 5, 6, up to 26. You'd have to do the formula for each one of those. I don't think any of us want to do that. And I am not asking you to either, so don't, if you forget this on a test, don't get upset at me that I made it so long. What's the better way to do this? Yeah, now we can do what you're saying, right? So the probability is directly asking me this, but that's equal to 1 minus, sorry, more than Jeff. That's equal to 1 minus probably x is,
What are you doing right now?
so probably more than 2.
Oh, it would be 1 minus the probability, you know what I'm trying to say, of 0, 1, and 2. You know what I mean.
Yeah, you mean blah.
Yeah, boo.
Of x less than or equal to 2, is that cool? Some of you guys might leave out the equal to, but 2's gotta go somewhere. More than 2 does not include 2, so it's gotta be the opposite. And that of course means, so let me focus on this. What I'm gonna do is I'm gonna answer the opposite of what the question wants, and the question's gonna get angry at me. The question's gonna be like, hey, what I asked, and it was a question, shut up. 1 minus this is what you asked, right? And I don't care if what I just said is weird, I like it. A little question getting angry at me. So I need to do probability x equals 0, 1, 2. And then add all those up. And that is the exact opposite of what the answer is going to be. Did anyone actually do this?
Yeah.
All right, let's all catch up to you. trouble so far? There's not any room for this, jeez. Ah. I really want you to understand, when are you allowed to do this? Anytime. If the probability question involves too much work and the opposite has less work, do the opposite and then 1 minus, right? That will work forever and always. All right. Here, I did this one. All right, Matthew, tell me what you got for a 0. Did you do 0?
Yeah, I got 0.001.
0, 0, 1, 1. Now somebody else do the 24. I'm sorry, the 2 ends in 24. And anytime we're doing something like this in class and you're doing it in the calculator and you're not getting the same numbers I am, just call me over, right?
0.0324?
Yes. So I'm assuming everybody else got that because nobody's calling me over. What do I do with all that?
Add it together.
Okay.
Or you could just do 1 minus, and then minus, and then minus.
So if I add all these together, I get 0422. I really want you guys to understand, that is the answer to the opposite of what the question's asking. So now I just do 1 minus that. And I get the answer to the question once. But please, dear God, does everybody understand just plugging 2 into the equation is not going to answer this? That would be exactly 2. This does not say exactly 2. If it says more or less or at least or at most, it's going to involve more than one calculation most likely. Right? Okay. And now you got this awesome little thing here. Right, so the mean is that kick-ass little dude.
Five point nine eight.
5.98.
Yeah.
And then the standard deviation is this still pretty decent little dude here. $2.187.
1.5.
What is it?
2.15.
2.15? Exactly.
Something like that.
2.146, or would be around that.
Standard deviation always has to be at least
Or
3 places, at least 3. So you can use 4 if you want to, yeah. Everybody cool with that so far? Speak now or hold your peace for a few seconds and then speak. I don't get a chance. At some point ask a question if you're not sure about what's happening. So this means out of any group of 26 people, we would expect 6 of them, right? Because we're humans, we're going to call it 6. We'd expect 6 of them to be satisfied. And can we now figure out what would be an unusual number to see? Anybody remember what unusual is? How many steps away? I basically just gave it away if you're watching.
2.
Yes, 2 standard deviations away. So you can even make it visual if you want to.
if it was usual, would it be 1?
Oops. Let's make it 500. Sorry?
If it was usual?
No. I want it really understood. unusual starts 2 steps away. Everything within 2 steps is usual. So if you're 1.97 steps away, you're in the usual range. If your z-score height was 1.97, you're not unusually tall officially. Is that cool? I like it. So if I add 2 steps, where do I end up? 10.272? I'll say that. Let's see. And then if I subtract 2 steps, Jeff, your decimal, there you go. Right, 2 steps up, 2 steps back.
1.688.
Start singing some old song. Say it again, I'm sorry.
1.688.
1.688? Yeah, looks like it makes sense. So would it be unusual to find 8 out of a group of 26?
No.
Hell no, because unusual doesn't start until after 10, right? So 8 would not be weird. A lot, okay? So this is related to if you flip a coin 20 times and you get 18 heads, wouldn't you kind of go, wait a minute? Would you? Do you agree with me? If you flipped a coin 20 times and you got 18 heads, wouldn't that kind of make you go, Yes? Okay. Especially if you do it again. If you flip it 20 times and you still get another 18 or 19 heads, then you're like, yeah, somebody messed with you. Maybe. So it's all about accumulating evidence. We're headed to the chapter that will be very much like a courtroom. It will be, is there enough evidence to convict this claim or not? Right? So that we're kind of headed that way. So this is all about, and that's one huge thing statistics is used for, is evaluating the strength of evidence. Right? Okay. I really hope most of you, now there are a couple problems in the homework that do manage to make this problem a little rough, but most of the questions I can ask you about uniform distributions have to be nice. They just, I don't know if you guys agree with me yet or not. You're all like, I'm not done with chapter 4 yet, man. Okay. But chapter 5, the big old freaking rectangle, right? Shouldn't be that horrible. So how does this get drawn? What I always get somebody to do this. What's the height gonna be?
17.
Yeah. I guess somebody turn that in. What's wrong with that? It's only missing the whole thing, that's all. Right? So this is the distribution itself. These are just the parameters of the distribution. So then more than 28 minutes. I've just drawn the area into my picture, shaded the area. How do I find this area? Subtract. So it's 11 wide times 1/17 tall. I'm really hoping most of you are quiet because this is easy. So I'm hoping this is easy. Especially compared to some other stuff we've done. You know, whatever the hell that is.
0.647.
6470.
I thought it was 3 places.
For standard deviation.
I don't know.
So remember earlier in the class I said you can take everything in 4 places and be covered, right? Standard deviation is 3
It is
places.
6470.
There you go. Kick ass. So you're covered. why are the next two questions really quick? What's probably that it takes less than 22 minutes?
0.
Because there's nothing out there, right? That's impossible according to what I've been told. And what's really weird about D? Why is it like doubly 0?
Because there's an infinite amount of numbers because it's a continuous scale. So the chances that you're going to get exactly 8 are slim to none.
Good. So it's like 1 out of infinity. So that's 0. What's even worse? Where's 8?
Not in there.
It's not even in there. So two things about it. Area 0, because it's just a point thing, so that's going to be area 0. Plus 8's not even a possibility at all, right? So if I would have said, what if I would have said probably x equals 27? That's in there. But, so what if it was instead, this equals 0? Bam! What if it was instead, E, x equals 27?
0.
Still freaking 0, right? So 27 at least is possible. But like Maddie just said, that's one possibility out of an infinite number. So that's one way. Or if you don't like that, it's the area. 27 to 27 is 0 width times I don't care height is 0 area, right? Okay. I like it.
So even if that's a probability of x equaling 39, it still equals 0?
Still equals 0. For a continuous distribution, the probability that it equals something specific is 0. Now, I took a little tangent. It's not really 0. It's this weird thing, but it's iota. But it's 0. Okay. All right. So I apologize for that. So there's a weird little shit to it, but basically for most humans, it would be, the answer would be 0. Okay, now, let's build up to the point where we can understand it back. Can somebody remind me, empirical rule, holy, what happened to you? Okay, there we go. What was empirical rule? It was the thing about normal distributions and what percentage is where. So let me kind of give this to you. So if I have a normal curve, can somebody remind me what percent is between -1 and 1 step away? -1 and 1 standard deviation away?
Is it 68?
68. Kick ass. What if I take one more step?
95.
Yeah, Jeff. There it is. Yes, Jeff. Okay, sorry. I just gotta give myself shit for today. This is how you count. 1, 1, 1. Okay. So, let's keep hold of that. Whatever method I give you to find areas in a normal curve, if we calculate this area, it better freaking be 68%. Yes? In fact, let me go one step further to make this easier in a minute to check this. Can anybody figure out what's the area from -1 to 0? What's this area here? If that's 68%, what's this area?
34.
34. I like it. Jeff, pick away. Pick away. Can somebody tell me what this is? This area here. The mean cuts it in.
Half.
So this whole side is 50%. That's 34. So what's this?
16.
16. Is everybody with? Okay. So that's one thing. That's one big thing to remember. The area below a z-square of -1 better be 16. Let me write that in a better form. What's area again equal to in a probability distribution picture? The area is equal to the probability. So the probability, the area below a z of -1 better frickin' be about 0.16 in a normal curve. We've actually known that for a while, right? So whatever piece of paper I give you that supposedly has all the answers on it, it better frickin' have that answer or we can all toss it. Okay. Second thing. I basically just gave it away, but in this picture, why are area questions easy? Because any subsection of this is a rectangle, and that area question is freaking easy. Could we? Can you imagine? And I already drew this up here once before, but a triangular distribution, where a subsection would be a triangle. Is that area formula difficult? What's the area of a triangle?
1/2 base times height.
Does that, anybody remember that? Really? Okay, so what's the area? All right, just because too many people just said they don't know. What's the area of that rectangle? What's the area of that rectangle? B times H. So what's the area of that triangle? What did I just do? I just cut the thing in half. So of course the area of the triangle is half height times base. No trouble. Half height. Okay. So just to make sure you really understand it, even if I do this, the area is still the height times the base. So then if I cut this in half, I make a triangle. So any triangle you ever see in the universe is half of a frickin' parallelogram. So of course its area is going to be half of the normal area. Yes? That's it. That's why the area of a triangle is half, because it is freaking half. Okay. All right. Now. So I already drew that. I already talked about that before. We've done problems like this because it's easy as shit. It's supposed to be. All right. Most of them. They can still make it freaky. So then we get this shape. Can we possibly be held accountable for this shape with what we know?
No.
Do you feel like it would be fair
No.
if I made you figure out the area of that, which is a trapezoid with one side that kind of souffled out or something, right? Do you guys understand what I'm saying? Isn't one side of this freaking curvy?
Yeah.
Do you have geometrical formulas that deal with some weird ass curve that's not a circle?
No.
No, hell no. Okay, I really want you guys with me. I really want you guys with me. So if I want to find the area in a uniform distribution between 2 and 7 or whatever, easy, because it's the area of a rectangle. If I want to find the area between -1 and 0 in a uniform, in a normal curve, that is going to be crazy hard, because I don't know what the hell that area for. It's not even going to be hard. It's going to be impossible, which sometimes is nice. It's like, is it possible? Let's go do something else. Too bad for you, though.
It is possible.
It's only possible because I have the magic answer. So let me give this to you, and then we got to talk about how this works. So what this is people had a computer crank out the calculus. I told you, remember last time I showed you the formula for that graph? And then I could do it today. I know what I'm going to do. Sorry. Remember I had failed at drawing the damn graph because the old calculator I was using was having extreme trouble, right? So now I'm going to use my new calculator, not the old and busted, right? But the new one. All right, so let me give you this. We'll talk about how this works. Do some examples. Oh yeah, sure. Did you get a second copy of the other one?
What other one?
This one here that we were just doing.
Oh, no, I didn't.
Here. All right, so this is a little weird. It's one page, right? Could have been so much more. So what did they decide to do? How did they decide to do this? Any z-score that I looked up, and real quick, looking at the picture, what does this chart work for? What's the only kind of distribution this chart works for?
Normal.
Normal. If it's not normal, I cannot use this. Okay, so the way this chart works, whatever z-score you look up, it will tell you the area below that z-score. So if I look up 0.60, okay, here's the other way. If I look up 0.60, that's the area below a z-score of 0.60. How about 0.62? 0.62. So this is the second digit. That's the first decimal digit, right? First decimal. Maybe. That's a little weird, right? Haven't really seen a chart like that before, but oh well, it's not that crazy. It's just different. So what do I want to look up? I want to look up frickin' negative 1.00. See if it's frickin' 16%. Frickin' stats. So look up negative 1.00.
It's not.
Don't say anything yet.
Okay.
If you round it, what do you get? 16? So if you round it to make the empirical rule easy for people to remember, yes, do you get 16%? Yes. Everybody see it? Negative 1.00, 15.87%. So to make it easy to remember, we rounded those. So that's 16%. Maybe? No? Okay. The crowd goes, All right.
So these are from the median, right? And we're counting z-scores? Or from the mean?
Yes.
Okay.
So the mean is 0. When you're talking about z-scores, and again, remind me, what the hell is a z-score again?
How many steps away a data point is from the mean?
Standard deviation.
There it is. So how many standard deviations from the mean to the data point, right? So what's the mean always going to become? How far away from the mean is the mean?
0.
0. So the mean is always 0 when I'm talking about z-scores, right? So when I drew that up there with the negative 1 to 1, I knew that was a z-score. That's how many steps away. With empirical rule, I can't handle a z-score of 1.28 because it's not my freaking rule. My rule goes 1, 2, 3. You know, that's it. Check. But now we got all the shit in the middle filled in. Now notice this. Can a z-score go more than 2 decimal places when you calculate it? Yes, right? So the chart is not going to be exact. If you use your calculator, you will get the exact answer. So why are we using the chart? Because your teacher's crazy, right? And I think you understand things better if you're not pushing buttons and getting the freaking answer, if you're actually looking at something and having to search through it to find the answer. So one thing I want you to realize, where is most of the information in a normal curve? Where's most of the data?
In the middle.
In the middle. So at the ends, look how little it's changing at the ends. What do I mean by at the end? Where am I at here on the picture? Where is this area at in the picture?
Far left of the curve.
Yeah, so I go down negative 3.49 steps. I go down negative 3.49 steps. So the area below that, freaking nothing, right? It's 0.0002. So the probability that somebody is less than negative 3.49 for z-score for their height is 0.02% chance, for example. Okay. Now, is it changing very much as I move up? So I'm going to move up like this as I go like this. Is everybody cool with that? 3.49, 3.39, 3.29. I'm getting closer to 0. So as I move up, is the area changing much? Is the area changing much? Come on, guys, right? Did it change by like 1 here, and then 2 there, and then 2, and then 3? All right, so that's me getting closer. Isn't it still a really low, not very tall out here, right? So of course, when I get closer to 0, now it's starting to change by, holy shit, look at that thing go crazy. Until it's really changing by a lot here at the end. All right, anyway, sorry. So that's one. So let's do a couple problems together, and then I'll throw you into that worksheet. How's How do I want to work this? Yeah, I guess I got to do it up there. I need paper. Paper. There we go. I got paper. So, let's try to do a few problems. What's the probability that a z-score is less than 0.91? So can you draw that first? The people that will make the most mistakes are the people that will not draw their picture. By the way, the instructions would say it's a normal curve, right? If it wasn't normal, we couldn't do shit. Tell you it's a normal curve. Probably z less than 0.91. Where do I draw the line for 0.91? Where is 0.91? Well, what's right in the middle? 0, like we just said. Mean's in the middle. Mean is 0 for z-score. So this is 0. So where's 0.91? Left or right? Right. Over here somewhere, right? So what's one thing you can tell me about this answer? The area is going to be bigger than what? Is it more or less than half? More or less than 50%? It's definitely more than 50% because the 0 cuts in, the mean cuts in half, right? And it adds a little bit more area up there. You guys see what I'm saying? So it's really good to know what to expect so that when you get an answer like 0.17, you're like, well, shit, I made a mistake. It's supposed to be freaking bigger than 50%. Now, for some reason, I always get at least one person just put the 0.91 wherever, 0, and there's 0.91. And I'm like, it's a number line. It's a normal number line. Negatives are below 0, positives are above 0, right? You guys, this picture is supposed to help you. So don't just throw the 0.91 wherever. All right, so how do you look that thing up? It's not a negative z-score, right? It's positive. So don't say anything. Try to find it, 0.91. All right, now somebody says something. What do you guys see?
0.8186.
Yeah. 8186. You guys see that? Okay. Really, now watch. This was 50%, correct? So what this is telling me is by the time I've gone up about not quite a full step, I've collected over 30% more, which makes sense because most of the shit's in the middle. So as I move in the middle, I'm going to collect more and more data pretty quickly. And end up talking, I forgot what the hell it was. 186, there it is, Jeff. 0.8186. Okay, a couple things I want to point out. What always makes me sad is when I'm teaching like a class that can be kind of difficult and students make it harder on themselves. I'm like, no, don't do that. Where did I put the z-score? I put it freaking down here. Where did I put the area? I put it up there, yes? Because 0.91, doesn't that look like 91%? Couldn't that be an area? Holy shit, that sucks so bad. You gotta be really, if it's a z-score, down there. If it's an area, up here. Do not be mean to yourself, right? Maybe. So what do you guys think? First off, can you draw this situation now? The probability that z is greater than 2.17. Just draw that situation. Up to you guys. So that's 0 because I have z-scores, right? Will that always be 0? No. There's going to be problems that aren't z-scores yet. But that's where the mean goes. And the mean is 0 if it's z-score stuff. Obviously, where's 2.17 go? Way the hell up here, right? And then where do I shade for the answer? What's the answer? Where do I shade?
To the right.
Yeah, above 2.17 is equal greater than 2.17. Which is pretty much exactly what we do with a uniform curve, right? Don't we draw it and then shade and then we find the area? That's pretty much what I was trying to do. So get us ready for this. So that's the area that I want. What sucks about that? What area do I get if I look up 2.17 on the chart?
0.9850.
Where is that though? First off, everybody make sure that Maddie's eyes didn't cross.
Yeah.
Could have happened. Is that what you guys got? Okay. No? What
Oh,
happened?
wait, no, I'm trying to figure out, so you go, where
So
you
this is
find
a
it on the chart?
positive z-score, right?
Yeah,
Positive, and then 2 point, sorry, 2.1,
Okay.
7. 2.17. So this first column is about to the first decimal place, and then the top row is the second decimal place. So 2.17. So 9850, is that right?
Yeah.
Can't trust my eyeballs. There we go. Where's that go in the picture though?
where the curve is?
On the
What
top,
side of 2.17 is that area?
Above.
No, that's
Below.
what we want. What does the chart always tell me? And please, dear God, let it make sense. 98%, is there 98% in here? Hell no, right? Which is another reason why you want to draw your picture correctly, because if you think the answer is 98, your picture's going to look at you like you're crazy. Picture's like, go home, you're drunk, sleep it off, try again, right? So yeah, this side. And again, the chart, very single-minded. That's why it's only one piece of paper front and back. They made it very single-minded. Look something up, it's below what you just looked up. So this, the minute I look up a z-score, I put what I find here. And I've already forgot what I found. So essentially-
9850.
Thank you. And of course, my picture tells me I'm not done, because that's not the shaded part. This should feel very familiar. How do I find the answer?
1 minus 1 minus.
Yeah. So I've got the one side, I want the other side, I gotta do one, I basically just found the opposite of the question, right? So what is 1 minus 0.9850?
.015.
Yes. Everybody look up negative 2.17. What is it? The
0.015.
frickin' answer. Why does that only make sense? The area that is above 217, how does it relate to the area below negative 217? Isn't it the same because it's symmetric, right? Remember the normal curve is symmetric. So there's a shortcut in there that if you understand it, use it, and if you don't, who gives a shit? It saves you like a second and a half. Right? You guys understand? Okay, maybe. Alright, so what about this? Here we go, the ultimate question. What's the probability that negative 2.18 is less than z is less than negative 0.16? Another way to say that is, what's the probability of z-scores between those two? That should help you draw it.
What would that be in word form?
Say again, sorry?
What would that be in word form
A
again?
quick way to say this is the probability of the z-scores between negative 218 and negative 0.16. So if you think of it like that, the picture becomes really easy to draw and shade. There's negative 2.18. There's negative 0.16, and I want this area there. Can I get the area for that directly from the chart? Of course not, right? Because the chart tells me areas below stuff. So somebody help me out. Look up negative 0.16. What area do you get for negative 0.16? What area is below that?
Point 4364.
4364. How does that relate to the answer? Is that the answer?
No,
Is that too big or too small?
too big.
Too big. Everybody agree? Because the actual answer is supposed to frickin' stop here, right? Schmack. And this thing went further. What the hell? So, what is in that bottle? What do I want to do to get just the area between here? How much do I want to chop off of this? I want to chop exactly this much off. Does that make sense? Physical sense? If this is the area from this all the way down, if I just subtracted the area from here down, would I end up with the area in the middle? Please let that be okay. So if this is too much, how much too much is this? If you just told me it's too much, how much too much is this? Exactly this much too much. So you just got to look this up and then subtract it. So if I look up negative 2.18, you guys get
0.0146.
0.146, I like it. Okay, there it is. Good. So this, 0.0146, so the area between is just going to be the difference of those two. I can think of this as a cookie cutter problem. I got a whole sheet of cookie dough, 4364, I'm going to cut out 0.146. And then we're left with what I want. And then I'm going to eat it. It's there. 4364.0146. 0.04218. You go too far, Jeff? No O there, dude.
Yeah.
There it is. Okay. Okay, I like it. So, look at the other side of that sheet we were working on earlier. You get some more problems, and you get some more problems. Felt very overish there. Look on the other side. More math problems. I just enjoy that you guys, some of you guys look at me like, it ain't been funny yet. Give those a try. The first three are exactly like what we did. I'm curious if anybody can figure out G and E. So the first three you should all be able to do. Then we'll see who gets D and E. Oh, I thought I turned you off. I guess not. That's an exciting part of the video. Alright, so let me catch up to you. I think. Hopefully. By the way, what we're doing right now, most of chapter 6 is going to be about getting the nuts and bolts down, about normal curves, probabilities, how to find them. So it's right now it's just the mechanics. Do you know how the chart works? Do you know how to calculate? And then number 2, we're going to have to calculate z-scores. We're going to have to do some more stuff. Once we get to chapter 7, 8, 9, that's where we start using this stuff to like test claims, to create these things called confidence intervals, which gives people more information about what we see. We start to use this kind of stuff. So I'm always worried students are looking at this as just, this is mathematical exercise, you get a number, yay, you keep going, right? And that's sort of what it is right now, because we're just getting the mechanics down. Okay. So we've got this one, 1.18. What do you guys get when you look that up?
0.8810.
8810? So you guys got this? Okay. Alright, now somebody else tell me. Negative 0.52. We want greater than, so we want that. But if you look that up, we're going to get below it.
Right.
So when you look up negative 0.52, what do you get?
0.3050.
Do it again.
0.3050.
3050?
Yeah.
And then, of course, to find the other side,
0.695.
695.
0.
Yep. By the way, remember, didn't I tell you guys about subtracting from one shortcut?
Yeah.
Make it 9, make it 9, make it 9, make it 10. You can see how that's going to be nice. I know you got calculators. Yeah. You should feel good as a human to kind of take ownership of this number system we created. Say, no, calculator, I got this shit. And then a second later go, let me double check. All right, I understand. So part C, put on there negative 2.63, put on there 1.49. I want the area between. So when I looked up, I want to look both areas up and then subtract them. Never subtract z-scores, because what is a z-score? Don't tell me the definition. It's basically where you are, correct? Which is not a good enough answer for a test question, but doesn't a z-score tell you where you are? You subtract 2 z-scores, you're totally somewhere else. You won't have anything to do with the question anymore. So you only subtract areas. That's what makes physical sense. So when you look up 1.49, what do you guys get?
0.9319.
9319. And then negative 263.
0.0043.
0043. So when you subtract those two, what do you get?
0.9216.
9216?
76?
There it is.
I can't read it. I do a box around it.
I understand. So it's that. Yes, nice.
Just for the second one,
Yeah.
should it be, 0.3015 instead of 0.30?
Let's see, I didn't check it. Let's see. Negative
Cause that's negative 0.52.
0.52. Ah, yeah, thank you.
Okay, I was just making sure.
You're good. I should check these. So so this is kind of nice that this happened. You gotta be careful, because this, of course, is 0, right? This is negative 0.50, negative 0.51, negative 0.52. Right? So yeah, it should be 3015. Just rewrite it, Jeff. Which would make this 0.6985. I like it. So it's kind of good that came up now. Because that's a mistake I can understand people making. What the shit? Did anyone? You're the one who made this thing, Jeff. Alright, so I'm kind of echoing what's in your brain possibly. What the shit? What does big P38 mean?
I know what it is. It's the percentile.
Yes. Does that strike a bell? P38 is the 38th percentile. What does that mean? It would be the z-score that has what percent below it?
38.
38% below it. So, where on the picture should it be? The mean has what percent below it?
50.
50%, right? So where should the z-score that has 38% below it be? Won't be up here. Yeah, be down here somewhere, right? It's got to have less below it, so it should be down that way somewhere. So at least I know about where to draw it. Check. On this side, bam! This is the z. Where do I put 0.38? What is 0.38 in this case? What is it? 0.38. It is.
What's your question?
0.38 is the percentage.
Yeah.
It's the probability,
Okay.
which is equal to the what in the picture? Probability equals
Z-score. Area.
area. Really
So-
want you. So I really want this to make sense. This question, part D, is the exact opposite of part A. See how in part A I gave you the z-score and I asked you to look up the percentage? Part D, I tell you the percentage is 38% below. I don't tell you what the shit the z-score is. So why should this work? Because math always is able to go both ways.
So how do we know it's below?
Because what's the definition percentile? 38th percentile, 38% below that. So if you scored on the 38th percentile, it's S, 38% of the people score below you.
So what if it was the percentile of 50? Would it still be below?
Yep. And the 50th percentile will be nice and easy, but I mean,
Okay.
right? Yeah. So this is 0.38. Now, if you can look up a z-score and get an area, you can look up an area and get a z-score. You just have to do it opposite. So what am I looking for in here? Do not look up 0.38. That's bullshit, right? Is 0.38 a z-score? No. 0.38 is an area, and areas are in the body. So get as close as you can to 0.38. What's the closest you can get to 0.38?
0.3859.
Let's see, 3.8.
Oh, no.
I can get closer to 3.8, right?
0.3821.
3.821 looks pretty good, but I can get closer.
3783.
3.783. All right, now for my people that don't know. Yes.
Now, would it be just no matter what the closest to the z-score, or can you
Notice a few places like the little star places.
Yeah.
Do you see how? Is there another one? Something that's over there. Do you see how it's like on both sides? It's exactly in the middle, so we can split the difference.
Yeah.
Now, if you want to, you can do like young Jeff had to do, and do what's called interpolation. And create a linear equation between these 2 points and figure out where it would be in between, figure out what the z-score. I don't think we want to do that. Do you guys want to do that?
No.
Doesn't that sound neat? Yes.
But can it also be, like, say if that was 0.3?
If you did cut this in half, I'd be fine with it.
No, like, if that was 0.38, the 0 one?
Yeah.
If that was 0.3801,
Oh, one.
would you use that, or can you not go over?
No, I would use that, yeah,
Okay,
totally.
okay.
This isn't about going over or under, good,
Okay.
good, yeah, we're not on the prices right. This is about, which one's closer.
Okay.
Yeah, and again, this is a product of the fact that we have a ink on paper, right? So how exact is that gonna be? Not very. Wouldn't the calculator just eat this problem up? Don't you think there's a way to tell the calculator z-score that tells you the exact area, no matter how many decimal places that z-score has? Don't you think that's true? Shit, yeah! Does Jeff care? Jeff does not give the first shit, right? Because that's just pushing buttons and not having any connection to what you're getting. Sorry. So we're gonna trade off stuff like this where I'm not quite as exact with hopefully a better understanding. So it's not this one. Is everybody cool with this one's closer? Do you see how this is 21 away and this is 17 away?
Yeah.
So this one's closer. So it'll be negative 0.31. Stay with me now. We're almost there. Stay with me. Start yelling. No, I'm going to start.
Wait.
So a z-score of negative 0.31 has 0.38 below it, about. Right? We would round it to 0.3. That's the exact opposite thing we did up here. So this chart converts between z-scores and percentages, either way. Right? So what about this weird thing? Where would that z-score go? Here's the mean. Where would I put the line for the answer for this part E? It's got how much where?
10% of a normal curve above it.
Above it.
So you go to the right.
So it's gotta be, yeah, it can't be down here. This is already 50% above it. So in order to have only 10% above it, maybe right there, right?
Yeah.
It doesn't have to be perfect. It just has to be on that side. And what sucks about the area that it gives me, considering that our chart only understands certain areas. Does my chart understand this area? What kind of area does my chart understand? Areas that are below the z-score. Is that area below the z-score? Is that area below the z-score? No. What area is below the z-score? If that's 10%,
90%.
this is 90%. So what's another way for me to ask part E? Find the 90th percentile. Find P90. All right, so what do you get? Don't say anything yet. Try to find the closest you can to 0.90. I think it should be a special one. Is it, Jeff? No, it's not. You could have made it special, but you didn't.
0.8159.
Yeah, okay. So the closer you can get to 0.90, I'm
Oh,
sorry, yeah, 0.90 is 8997, right? Is that cool? That's freaking close as shit. And what z-score is that? 1.28. Not bad. What do you guys think? Is that enough for today?
Yeah, I think that's good.
All right, I don't, so I'm joking.
Okay.
Oh man, talk about, I'm a math teacher already. Talk about a quick way to make people hate you. Oh man. So that's enough. That's good. We have until next time to finish chapter 6 anyway, and we're already halfway done with it, so that's pretty good. Cool. All right, and don't forget, first thing, put it on the chapter 4 next time. Don't forget your IDs.